So, hi, I'm Bruno. I'm just a contractor around. I'm not going to talk about me too much. But if you want to get the slides of the talk, it's on my GitHub. There is also the code I'm going to use. The slides are mostly anecdotic. I would like to poll the audience a bit because this was supposed to be about how to get the extra out of the library. But then when I did a poll for the meetup, I found what I usually find, which is hate toward mocks. And yeah, so I'm going to try to tackle that as well. So I would like to know how many of you have used mocking tools, or Mockito in particular? How many of you have used the Scala version? Cool. And then how many of you think that mocks are shit? Good. I was expecting more hate. And also, how many of you are familiar with the tagless final pattern and the ID monad from cats? Cool. Then I'm going to leave that for the last. So what I'm going to do is use mostly code. And so an introduction to the problem is we have a REST API where we can trade currencies like dollars by pounds or euros by dollars or whatever you want. And this API, we need first to get a token, so then we can put trades as authenticated. And then we also have the requirement of logging successful trades in an event log. Imagine that we are doing event sourcing, or we have a Kafka topic that we need to send the trade so some other system can do something with it. So yeah, I hope the problem is not that weird. So yeah, let's go into the code. So what I have here is basically I defined a trade that is an HTTP client, which some implementation will, given some set of credentials, will get back a feature of a client response, which is basically an either. So I can get back either the value or some error in the API. And the error may be something I don't know, or unauthorized because the tokens will expire every half an hour, even if I use them. And then once I have the token, I can get either prices, so current rates of currency pairs like GBP USD, GBP Euro, whatever you want. And I can submit orders for which I can say, hey, I want to buy 100 pounds with at this rate, which would be, I don't know, $1.3, well, 1.2 thanks to Brexit. So yeah, that's pretty much our HTTP client. And then the event logger is even easier. So it's basically a unit method where I just send some events, and it's a fire and forget. But we need to be sure that we are recording these events as part of the execution. And I've modeled the production code as an actor. I'm not going to show it because it's not an actor. It doesn't use akka because I don't want complexity, and the code is horrible. But it's just there so I can get green or red tests if I want to. And because as developers, we should be spending more time in the test code base than in the prod code base, because otherwise we are probably not writing enough tests. So and that's why I'm really keen in getting the right use of testing tools, because tests should be nice. Tests are the documentation of your system on top of ensuring your system does what it's supposed to do. So a test should ensure the system does what it's supposed to do and also tell me what it's supposed to do. And what I can see in many tests I found over my career is that they may be trying and ensuring what the system does, but sometimes are so complicated that I cannot understand what they do. And because of that, sometimes they are testing the wrong thing. And that's bad. So, but because all the hate that mocks get, I went and I did my best to don't use them, for an example. So this is my first attempt with I mean, after a few iterations, but what I end up with is I have a stub that extends from HTTP client, and then I always want to be nice and log in, unless I want the opposite. But then I want an exception if I call a method that it wasn't supposed to be called. And I do this once because otherwise, if I were to do new HTTP client in each test, it would be even more boilerplate. And so for the event logger, I have this mutable collection that is already itching me. And then I'm going to be recording everything that that is passed to this method. And I'm going to be putting in this collection so I can basically do assertions. So let's check the simplest use case, which is the one we will start with, as we should be doing TDD. Or I was when I was doing this. And so I want to verify that as soon as I spin up my application, I log in. And so in order to do that, I need to create an instance of my stub. I want to be sure that I use the right credentials, so I'm going to record them. And so when somebody calls login, I'm going to record the credentials, and then I'm going to call super because I know that that returns the right token. And so I create my actor, and then I just can do this verification. Now, what I can see already is that this is not nice to write, and it's not nice to read. And the intent of the test is to try and see if I'm logging in. But then in order to understand what I'm asserting and why, I need to go and understand how this works. And even if I wrote it myself, if I did it 2 months ago, I don't remember, right? It's like if someone else had written it. So now the second test case is basically I want to trade. I went about buy 100 pounds at this many dollars per pound. And this is just a nice test DSL that I implemented because otherwise this would look like this. And that's horrible. And as I said, I care about my tests and I like them to read as a book if possible. So I have another talk that is linked in the PPT on why and how to do these things. But please put love into your tests. So yeah, here we have a similar pattern as before. But now we want to ensure that we are passing the right token to our submit order method and the right order. And if after we record that, we will return a successful future, which has a right because we want everything to pass. And we have this status which has created. So an order status is basically the answer to an order. I send an order and the market tells me everything went well, everything didn't go well, or you just bought this much, not necessarily what I wanted. So then I'm going to create this order, and I'm working with futures, so I need eventually, sadly. And yeah, so I'm going to start asserting the internals of my stub to see if my application is sending the right parameters. And then finally, I'm going to be checking that the events my stub recorded contain an order status event, which is basically a class. Now, notice I'm not using a case class here. And that's on purpose because I'm simulating this being generated code or something. So basically, the whole point is this is not implementing the right equality. This is doing equality by reference. So if I were to do this just out of the blue, this test will fail. By the way, all these tests are passing right now. So what is going on here is that in the same way that cats provide EQ to override equality, Scala test has a sister library called Scalactic that provides a type class called equality. And so you can define that in your test code. So you can either, in this case, delegate the equality onto the order status that this event is going to hold, or you could be rounding numbers because your application spits out big decimals with a bunch of decimals, but you just want to verify 2 or 3 of them. There are many scenarios in where you want to control how the equality works, and you don't want that code to be part of your production code, or you can't because it's some object coming from a library or something. So this is something I would like people to take. Scalactic is really nice, and it's integrated with Scala test because it's part of the same project. And then this PrettyFire is also from Scalactic, and it's basically a partial function from any to string. What Scala test is going to do is, if it has to fail and show me the objects that were involved in the failure, it's going to look up for a PrettyFire in the implicit scope, and if it finds one, which it's going to find, but this is overriding the default one, of course, it's going to use this to print our objects. So the good thing is that we can add the field names, which sadly the case class equality toString doesn't do, or we can even get it to print our objects using the same syntax I'm using to create them. So the good thing is that I can copy and paste from the console if I wanted to. And what I realized is that now my PrettyFire is usually in production code because I want a log on the same format, because then it's super easy to see a log in Kibana or whatever you use and copy and paste to reproduce a scenario that didn't work in prod, for instance. So you want your logs to be nice, and if you are tailoring your DSL, your test DSL to be nice to read, it's nice if the logs match with that, because then you get the best of both worlds. And this is why the talk is called Mockito and some other tools. So yeah, so coming back to the subject of test doubles, this is already something I'm not liking. And when I go to the third test case, which is if the token is expired when I try to trade, I should log in again, get a new token, and try again. So basically what I want here is I'm going to have to return 2 different tokens because login is going to be called twice. So I came up with this. So if I call it more than twice, the iterator will blow up. And then here I'm going to be recording the tokens in the same way. But then I had this if that if it is the token 1, then I'm going to fail saying you're unauthorized. Otherwise, I'm gonna be successful. And the verifications look pretty much as before, but now I'm testing that. I call submit with both tokens, and then I call the same order was passed twice, and at the end of the day, I have the event here. So what I'm not liking here is that this thing is already too boilerplate-ish, and it has a lot of behavior. And that behavior is hard to understand, and as soon as it's not just returning a value, you should test this. Because we write tests for simple functions in production that just do if, whatever, because sometimes we mess it up. So why would you try to also complicate your test? I don't like it. But it is what a lot of people, I've seen a lot of people doing this. Not sure why. So I was like, OK, I may be the idiot. So I'm going to try to go better. And what I did is I tried to create a generic stuff that I can reuse, so I can maybe reuse it in other tests as well. And what I'm going to do is to construct it with an iterator of responses for each one of the methods I'm going to call. And then this is going to just do collection.next. The semantics are the same, which it gives me a slightly better test, right? But still, I just create this, and I just passed an iterator of tokens and an iterator of statuses, and it's not really clear if I didn't write this why I'm doing that, and I need to go and look at the thing and understand what it does, and that defeats the purpose. I'm not just being able to say, okay, if something goes wrong, I'm going to try to log in again and stuff, which is what this test is all about. So then the next step would be, OK, let's use traditional Mockito. And I did that, and I realized why some people may think that it's not really great. And it is because, well, now I have all my setup here because I separated the stubbing from the creation. So I can create my 2 dependencies and then my test object all in my setup trait. And then I can say as well, OK, whenever somebody calls you with login, just be right. But then when I look at my test, it is slightly better. At least the setup part is better. I can say, OK, when somebody submits an error with something, I don't care. Return this future. And I'm not caring on purpose because, as anyone that uses Mockito knows, if I mess up the parameters, rather than telling me it's going to return null, then I'm going to end up with a null pointer exception, which is maybe inside a lambda and tracking that stack traces. God help you. And so that's why I do any here, and then I say, okay, I still have to verify that the methods were called with the right parameters, because I'm like belt and braces guy. So I want to be sure the test is not passing because I'm telling Mockito to pass. It's passing because all the assertions I want work. But then we have this problem that the equality doesn't work for this order status, so I cannot just rely on Mockito doing the equals. I have to use this argument capture, which is a bit hideous. But it works. I mean, this test passes. This test also passes. I mean, I'm saying here, okay, the first time that somebody submits an order, please return this future. Otherwise, return this future. And I still have the assertions, and this has to be called twice. Again, it would be hard to argue that this is better than the other one. At least, I mean, I have a standard API, and it's more declarative, but I still think it's not great. So if I happen to move to Mockito-Scala, things start getting better, because I'm using Mockito-Scala test here, which is a submodule that integrates with Scala test, of course, which allows me to use Mockito in strict mode. Strict mode is a mode in where if you call a mock in a way that is not prepared to, or it hasn't been verified of, it's going to blow up, but it's going to tell you, hey, somebody called this method. I wasn't either expecting it, or you told me that you were going to use this parameter, and this was the parameter that got passed. And that happened in this line of code, which means that the only thing I have to verify now is the right interaction. And that means that now I can say, I can be more specific with my setup and say, OK, when somebody submits an order and I want this order that I just created, then return this future, please. Here, I just left the captor because the captor is nicer in Mockito-Scala. But the truth is that I can actually use a standard verification with equals, because the equals of Mockito-Scala pulls an implicit equality. So if the equality is in scope, that's going to be used. And it also pulls a PrettyFire, because it will prettify the objects on errors. And so here, it started looking better. I mean, I'm saying, OK, when somebody log in, please return the second token. This is because the first one was already used as soon as the object was created. I can create 2 data objects. Please never mock data objects. And then here, I'm saying when somebody submits the order, and notice that I'm leaving the token out because it's defined as implicit. So Mockito can take care of that. And the second time, I want to be specific, because token 2. I mean, you can pass the token 1 here if it has clarity, which I think it does. I was just trying to prove a point that it works. So here I'm saying, OK, here fail with a left, and this is unauthorized. And then the second time, if they call you with the new token, then succeed. And then hence, the only thing we need to verify is that this thing was recorded in the event log. Now, the good thing, I think, from Scala is that we can be more flexible with the language, and it has macros. And that allowed me to create a new syntax for Mockito, which I think is way better. And so basically, the first thing is that you will notice that you just say, this is my piece of code that I'm going to be working with. And I can say it was called, or the same way is being used for stubbing. So I can say, this is my piece of code. And then I can return something, and it works. And same here. When I'm verifying, I'm just saying, OK, when somebody calls event-logger.record with my status event that holds the status I'm getting back from the HTTP client, I just want to verify that this was called. And notice that the equals to is not here. And that's why, because one of the things that the macro does is to wrap anything that is not a matcher into an equals to matcher. So you always get the equality for free. You always get the PrettyFire for free. And you get rid of the problem of mixing arguments and matchers, which you cannot do in Java Mockito. And it's really annoying, mostly when you have implicits. But because you suddenly, as soon as you put a matcher, if they were working because the implicits were being pulled, now you start getting like, oh, I was expecting 4 matchers, but you gave me 3, and I was like, oh, where is the missing one? Ah, fuck. So I think that most of the people, I hope, would agree with me that this setup is easier to read than the first 2 no mocks examples I've got. But it is still a bit boilerplate-ish, I think. So now the cool thing is that if we have cuts, or if we just add cuts for testing, I am not judging, we can mix in this integration, idiomatic Mockito cuts, which basically will add, among other things, sorry, I didn't show you before, I think, that you can create a mock and stub it in the same line if it is a very simple one. So yeah, that's cool. So the main difference here is that instead of returns, I'm saying return F, because this means that returns F is going to be pulling an implicit applicative. So it is important that in your imports, come on. Okay, it is important that in your imports you get either your own applicative or you have an implicit. You need an implicit applicative of your type in scope. And in the case of dealing with features, it's important also to have the global context, the execution context. But the cool thing is now here I got rid of the future. So because I'm saying that if there is an applicative for the type this thing is returning, then and all of this is type safe, then the framework knows, okay, this guy is going to be returning a future. So if I can find a future applicative and then do pure inside the stubbing, so I don't have to do it here. But applicatives compose, so you also have returns FG, which will pull 2 applicatives in this case. It will pull the applicative for future and the applicative for either, which means that I can just work on the types I care about without all the nonsense of the monads that on the scope of the test, they add noise and not much value. Because I can say something like, okay, I'm going to return this status, and if I want a failure, I can say something like, it raises this, whatever it is. So the language is also consistent with what an applicative or a monad error does. It's actually applicative error, sorry. And this is raises G because raises is always in the scope of an applicative. Raises doesn't make sense with a plain type as returns does. So there is no raises F. But we have raises G when we have to get an error on the second layer of monads, because we have the error here on the either. If we were doing races, we would be getting a future error with something inside. And yeah, I think this is super nice. The only thing that we couldn't get rid of is the eventually, because under the hood we still have futures. But so far, I think that if we do this and I compare it with this, I don't have enough screen space, but I think that this reads a bit easier than all of this nonsense. And it's standard, and all my tests will look the same, and I don't have to write it, and I don't have to test it, because this thing could get uglier very quickly if I'm testing more complicated interactions. And also, I don't have to test all these parameters because it's not that I'm not testing them anymore. The framework is doing it for me under the hood, which is really cool. Now, a common pattern I've seen is using tagless final to get rid at least of the future. So how that would look like is that I have a different branch where called IO, which is wrong, but whatever, where Git is not working because reasons. Git compare with branch, come on. Okay. IntelliJ, this is being damaged. Let me change branch and or maybe I need to get out of presentation mode. Let's see. Yeah. Can you see? This is not going to work. Let's change branch. So the main difference here is that I have this higher kind of type. So instead of saying I'm going to return a future of something, I'm saying I'm going to return an f of something, and then f can be anything, which is good because then I can go and into the test and coming back to the no mock one, I can just say that my HTTP client stub uses extends HTTP of ID, and ID is a magic alias, so ID of A is A, and this is weird, but it actually works. So basically, what happens is that the future gets completely removed from the signature, which means that now stubbing something is a bit simpler because I don't have to do future.successful. I just return the value. But other than that, all the rest of the nonsense is still there. I just don't have the future. And I can also get rid of the eventually, which is a small win. I don't like the eventuallys if I can get away with them. Now, the thing is, if we go and look at the Mockito cats example, apart from having these IDs here and not having the eventually, the code is pretty much the same, which means that if it wasn't because getting rid of futures is nice, and if you were just using tagless final for the sake of testing, you can stop using tagless final and get rid of all that complexity in your code, and less code is better code. So it's kind of similar to what happened in Java before. People were creating interfaces just for the sake of creating a stub, and then the implementation in prod was like my interface imble, because that interface that was nonsense. So mocking libraries allows you to mock concrete things and be sure that none of the actual implementation is going to be used. And so you can reduce the boilerplate and the nonsense in your production code, which is nice. I mean, I'm not saying that tagless final is bad, but if the only reason you are using it is for testing, you have an option. And so, cool. And so, yeah, again, this test setup saying, this is what's going to happen, and these are my data structures that I'm going to be playing with, and this is how my mock is going to behave, I think it wins a lot versus having all of this, or even having this and having to go and say, okay, what is this doing? How does this work? Okay, fine, I need to go and look on this and do something. So yeah, that's what I mean. Mockito-Scala has a ton of other features that it would take me hours to go through them, so I'm not going to. But please check the documentation is quite all right, I hope. I'm working on that, but that's always a lazy thing that you write the library and then documentation. So if we go back to the presentation, so again on the question, why mocks? Why do we need them? And I think we need them because writing tests and assertions is much better than writing stuff. I mean, this is my final goal, so I should be focusing in this. And declarative code is always better than imperative code. I don't think anyone will disagree with that. Standard and consistent behavior. I mean, if we have many developers using Mockito, there are maybe 2 or 3 different ways you can use it, and we can agree easily on which one is the one for this project. Now, there are hundreds of ways of how each developer would like to handcraft stubs and position them and try to reuse them, and all of that adds to the mental work of understanding what's going on with the test setup rather than understanding what's going on with the production code, which is what we care about. it leads to shorter tests. And if for some reason you need a slightly smarter thing in where we need to return one of the parameters or do something simple, we can rely on answers, and the same framework allows you to build something similar to what we saw before, and in which we can have behavior, but without having to define extra classes or anything. And yeah, as anything, there are places where you shouldn't be using it, please. And so the good practice is to never mock library stuff. So notice that I was mocking my trait that represents an HTTP client. I wasn't mocking Akka HTTP or whatever HTTP framework you like to use, because usually the DSLs are not really nice for mocking. And also, if those guys change something, you are in deep trouble. So the good practice is to isolate that behind some implementation like we did here, do an integration test to verify that works, and then just mock your interface. Yeah, Akka actors do not mock them, but if they have dependencies, you can inject them. Pretty much what we did in this test, but with proper Akka. Pure functions. Usually with pure functions, I mean, by definition, you don't really need mocks because it's data in, data out. So usually they are better candidates for property check testing and maybe some tests that define what they do. Trivial dependencies. I don't know, if you have a function that you use an ID generator so you can be deterministic in your test, just create a function that always return my ID or something, but don't use a mock for that. And yeah, data classes, use test builders. Which is something I didn't show, but I was using there. That's why I could use that fancy syntax. But yeah, if you have data classes that are too painful to build, just create functions in your test code that can create those classes with sensible defaults that only make sense for tests, and then reuse them. And so you can override only the parameters you need for a particular test, which leads to shorter tests. And if I change the definition of the class, I need to touch one place. And also I can use them. So if I have something that creates a person and something that creates an address, the default parameter for addressing a person can be whatever the address method returns. And yeah, so the key takeaways for me is that we should be giving more love to tests. We should be giving, I mean, I can see people like spending half an hour trying to find the more functional or the more beautiful way to compose something in the production code. And then they spend 5 minutes, if we are lucky, writing some crap test that no one is going to ever understand. And that's not how it should work. We should have tests that verify each one of the possible behaviors of that function. And that should be telling me what that function does. Less code is better code. So the less thing we write, the less thing we need to maintain, the less thing we need to test. As I said, the tests are documentation. Invest time to learn testing libraries, the same way that people read books on cats and Scala set and whatever else. I don't see many of my colleagues reading books about Scala test or whatever testing tool you like. And so we are less productive in writing tests, and we may end up with uglier code. I don't know, if we didn't know that equality exists, we may end up resorting to some other ugly Scala test code that doesn't make much sense, and we have to do that all over the place. And again, the test code base has to be bigger than your production code base, because to test a function that does a few things, you may end up with many tests that have your setup and your expectations and everything. So the more efficient you are writing tests, the more efficient you are overall. Because, yeah. And the answer to the question, do we really need mocks in Scala, or I guess in any programming language, is technically no. I mean, I showed 2 examples where I'm not using them, but they help a lot. And you know, any library we use is like that. Do I need the library for actors? Not really. I can write my own. Do I want to? No. Same for anything. Like, do I need Cersei? I can just write the parser for JSON, but I use Cersei, right? So not using something because no reason, because I think that things are evil is a bad argument. People is evil and use the things in the wrong way. That's the thing we need to tackle. It's not the problem with the tool. Well, if you use the vanilla Mockito in Scala, it may be the problem with the tool, but this is the whole point of this library. And further reading, this is a couple of other talks I give about testing quality and how some internals work. But this one I find quite interesting. It's a paper from a few PhD people that they argue that auto-generated spies simplify testing in complexity, and they led to better test and to more correct behavior. And the example they use in the paper is the iterator in the Scala standard library. It was broken for years, and the laziness was working wrong. And there was they show the test. If I have, I don't think I have time, but if you check the slides or even the paper, you will see that they had a massive test with a lot more nonsense than my example of the HTTP client. And the errors when that fails is something that makes no sense whatsoever for whoever is reading it. And they just replace it with 4 lines of Mockito. And when that fails, you get an error that makes sense. And they, they are academics, so they run a bunch of statistics on replacing tests and how much that reduces the lines of code and the cyclomatic complexity and everything. And mocks win every time. Well, spies in that case. So I'm not the only one arguing for more auto-generated code for testing. And yeah, that's pretty much it. Thank you for listening, and I hope that you give these things a go. And yeah, any questions?
Okay, any questions?
It was either very good or very bad.
Okay, I actually have a question. So you went through, in one of your slides, you went through everything that we shouldn't use mocks for.
Yep.
But I guess my question is, what then should you really use mocks for?
Well, I would say that usually they work very well when you are trying your side effects. Both of the things I was showing were effectful code. So when you compose your pure functions and everything, you have better tools to test that probably with property checks or just plain data. But when you are in the outskirts and you need to see how the overall thing works against the external world, or if it is an actor and is interacting with some, not all the Scala code is pure, sadly. So if we are using actors, or if we are using play and we have to deal with the database or some other microservice or whatever, and as soon as we have effects and stuff that can change because the network or because we got unauthorized, I think that mocks play really well there, because you can easily say, okay, given this and this and this happened, then my system should do this, and I'm expecting to react like that. So yeah, that's the most the stronger use case I can give in Scala. And even if you do pure functional, like I did in the IO branch, at some point you have to do side effects. If your program doesn't do side effects, it's completely useless because it doesn't interact with the world, right? And we need to test that. So that's where mocks shine in Scala.
Yeah, and that's the uses that I've found for them as well, as where you've got, you kind of have your own system, which hopefully is fairly pure, and then you have your external world.
Yep.
It's the external world that is really good to mock.
Yeah, but yeah, always put this layer of your traits hiding the external world, and that's integration test.
Another question.
Thank you very much for the presentation. I was going to ask, one of the things about mocks, especially, programs or libraries can be as functional as declarative if you like, but at some point you're not just interested in the data, but also in the control on chain. this method has been called, has
Mhm.
this value been used, has this object been actually accessed. At some
Yeah.
point, you really want to check if some action, if some side effects has or has not taken effect. Not just isolating from it, but actually checking it, right? That's the one thing that I found. Yeah. No, I think that the question is, how does that play when you are with the catch component that you were
Yeah.
describing a catch library for Mockito, right?
Yes. So the CATS integration is mostly to use the applicatives to make the stubbings simpler, so you can let the creation of the monads out. And then it does another thing, which is if your system is using CATS EQ for something, because reasons, and you have that EQ in scope, there is an implicit that automatically will wrap that EQ into an equality. So Mockito would use that EQ to do the comparison, so you don't have to do it twice in production and in test code. But yeah, it's not much more than that. It's using CATS to simplify stubbing and also using this equality thingy. Yeah. And then for if I want to verify what parameters have been passed or not, it really depends. If you're using strong types, usually the compiler does that for you. But in this case, with the token, for instance, I really want to verify that the second time I call the API, I'm using the new token. Because if I have an error in my production code and I just keep the old token, and I don't verify that, and I say, okay, whatever happened, like with the iterator, right? If I have first time you call, you get called fail, and second time succeed, and I don't check which tokens were used, that test is going to be green, but it might yield a false positive. So it is a lot of pain to check that, but I think it's worth it. But if you use strict mode, all of that is done for you automatically by the framework, which is win-win. So you only put the assertion that makes sense from the business point of view, and if there is only one way with the data flowing that you can get to that, like in that scenario, then that will pass, and it's not going to pass if anything happened in the wrong way in the middle. So you get the both you get the best of both worlds and pretty much for free.
Thank you. Any other questions? No? Okay. Well, thank you very much, Bruno.
Cool. Thank you.